Chapter 2, number 33. A car is traveling due north at 23.6 meters per second. Find the velocity of the car after 7.10 seconds if its acceleration is A, 1.3 meters per second squared due north, or B, 1.15 meters per second squared due south. So this is actually relatively straightforward. I guess we traditionally do draw a picture for everything, so we'll do crazy quick picture for the car. And we know that we're going to say that this is t equals 0 and this is t equals 7.10 seconds. And we have an acceleration that would be different for the two of them. So I'm going to do the first one for A. It would be something like this. Let's say it's traveling north, right? So we'll say this is part A, 1.30 meters per second squared, with an initial velocity going this way. And then we want the final velocity here. And we're just really going to say, take the definition that the acceleration, which we're assuming is constant and therefore is equal to its average value, is delta v over delta t. And so we can solve this over and say delta v is a times delta t, but delta v is v minus v0. And so that leads us to saying that we have that the v in some time is v0 plus a delta t. So it's 23.6 meters per second plus 1.30 meters per second squared times 7.10 seconds. This is 23.6 meters per second plus 9.23 meters per second, and then we want to check our sig figs, but it's 3 in both cases, so that's fine. And then we add them, so we have that plus 23.6 is 32.83 meters per second, but we should only have to the nearest 10th place because we only have the nearest 10th over here, so we end up at the end with 32.8 meters per second. So in this case now we have, for part B, we have an acceleration which is south, so it points opposite to the motion, and has magnitude 1.15 meters per second squared, and that will show up by saying that our acceleration is negative. So we have the same kind of equation that v is v0 plus a delta t, but in this case the v0 remains 23.6 meters per second, but the acceleration is minus 1.15 meters per second square times the 7.10 seconds. So that comes out to be minus 8.165 meters per second. When we combine that, it's out to be 15.435 meters per second. But again, we have only the first decimal place of accuracy there, so we can only have one decimal place, first decimal place in this case, so we get to round to 15.4 meters per second.